So it's great to be here, to see many of you all again. I mean, it's impressive to see some of you have gone and come back, and some are putting a good word for us out there. And as you know, the Allen Institute is a very special type of research institute, and not-for-profit. It's organized in a different way. We do moonshots. We acquired large data sets, and we publish everything openly. And the amount of data that the Allen Institute has collected, not necessarily what's out there, but since the beginning, is tremendous. It's around 350 petabytes of data, which would put us almost in the scale of things like the CERN in Switzerland. So when I came in, and this was before, I think before ChatGPT was released, but I knew something was in the works with OpenAI because an ex-student was there writing this, Sam. And we had some discussions, and we thought we need to do something. How are we going to look, organize, and even interpret this data? And multimodal data, it's not all the same. And so we decided to actually hire a CTO for the institute. And there was a search, but even before the search started, I was lucky enough to be introduced to Andy Hickl, who had worked with Paul, and we hit it off. And so I encouraged him to actually apply for the job after explaining we couldn't even be in the ballpark of salaries of what he was making. Anyway, so Andy, can you tell us a bit about how you joined and you know, at that moment, and what you've been up to, and what is it that you're trying to build here?
So I'm Andy Hickl, I'm the CTO, and I have the best job in the world. And it's no small part to the fact that the contributions that alumni like you have made over the years, the fact that we have petabytes of data to work with, the fact that we have intelligent people who are excited about the work they do, and the fact that we have world-leading problems to go solve is really what an AI specialist needs to actually be successful. And so I remember the first time I met Rui, he didn't say hi, he didn't say hello, he said, "You have unfinished business." And I said, "What do you mean I have unfinished business?" He said, "Your buddy Paul needs you." And I said, "I love Paul and I miss Paul, and but he's been gone for 5 years at the time. And it's hard to believe that he was gone 7 years here in October." And he said, "Well, what do you mean that Paul needs me?" And he proceeded to lay out a case that was unbeatable for me. He said, "We're a world-class data collection organization. We've collected petascale data, but we don't necessarily do enough in terms of making sense of all that data. And making sense of that data can actually pay real dividends, not just in terms of the impact that we deliver in terms of the translational outcomes or the scientific outcomes, but actually how we do science." And he said, "Really, we have 3 problems that we need you to go take a look at. One is we need to make our data easier to use. We have all this data and it's fragmented, and some of it's stored up on the 6th floor, some of it's stored in Google, some of it's stored in Amazon, some of it's stored in laptops and desktops. And it's still too hard to use even internally." And the second thing he said was, we need to kind of change the culture around AI. We don't just want to invest in AI, we want to invest in that, and how the elements who can actually be a leader in terms of how AI works for science. And the third thing we need to do is we need to change the culture. We need to start thinking about sense-making as a kind of first-class opportunity for things we take on, and it's not just kind of enough to build a data set and leave it, park it out on the website for somebody to come and use, and hopefully somebody that makes sense of it. We need to be making sense of it ourselves. And so we spun up the Office of the CTO, really, which is just a fancy way of saying a technology organization that has shared responsibility for all the science units that are out there. And we really focused on 3 things that parallel those areas of investment that he called out. One is in terms of data, in terms of helping the science units and the technology teams that we couldn't do anything without, in terms of making the data infrastructure and the insight more palatable. We've hired Grace and Jess, who are the core of our AI team. and a really great set of specialists to really start thinking about how we could center on centralized infrastructure for AI. And then we spend a lot of time thinking about how we actually think about changing the ways of working. And you know, anybody tells you that they know how AI is going to change science or that AI is going to put scientists out of business, they're kidding you, because nobody knows. Despite the fact that people have won Nobel Prizes in this zip code for applying AI to biology, the field is really open, and we really need to figure out exactly how to ask the right questions. How do I align our ambitions with the kinds of problems that are out there, and really how to make things work at scale?
Yes, absolutely. I couldn't agree more. It's not true that I phrased this so elegantly in 3 points. I remember I must have said something like, I don't think this will help us. I think it will be existential.
That's right.
That whatever institution doesn't have these will not exist in 5 to 10 years in science. And of course, then as soon as you joined, ChatGPT was released, and everyone realized these in one domain, but it's happening in every domain.
I think it's important to point out that our ambition is not just to show up and do some AI in science. It's to actually lead in the way that AI is applied to science. That guy over there is going to hold us to make sure that we actually achieve that goal.
It's existential. Yeah, it's also a good lesson for how to get people that you can't afford with a good story, which leads us to Grace. And again, with Grace, I was in the parking lot of Broadway Bound in one evening, and Andy says, you know, I really want Grace, and she was worked at Boyden, and I knew of Grace, but you know, there are these constraints, and I'm like, just do everything you can, and promise flexibility, agility, things we don't have, say we fly, and you know, beg her to just try and see if she likes it. And I actually also wrote a message that night, and so thank you, Grace, for joining and leading our team that builds actually AI tools to enable new types of discovery. And so what type of research you think is possible with these new tools you're building?
Yeah, I mean, I think with our group, we're really focused on building data-driven AI models that integrate, you know, all of the great data that we have across all the institutes, but also bringing it together with external data to help us get deeper scientific insight. I think part of that is kind of the classic, building large multimodal models to understand our data better. But the second part is also building models that help us move the science forward to the next step. So how do we use these models to prioritize what kind of new data collection would be most valuable for us? How do we use these models to make predictions of how biological systems will respond to over time or to new perturbations, to really kind of make generative hypotheses about what might happen next that we can test in the lab. And then also, I think, to start to use AI models more effectively to connect the dots from kind of the molecular basic science work that's happening here and elsewhere to the clinical questions that are facing patients and clinicians, so that we really can see the impact of our work more effectively.
Yeah, amazing. And what, I mean, everyone's trying to use AI in a way, right? And so you're here, everyone is doing AI in science, AI in health. How are we different or distinctive, or what are things that you're trying to focus that are a little bit different or special?
I think rather than focusing on like a single model that's focused on a single question, we're really trying to empower scientists with the tools to be able to make AI their own, so that they can really amplify the science that they want to do. So, I mean, there are opportunities for AI across the whole scientific process: hypothesis generation, data collection, data analysis, getting some insight, communicating it out. And I think sometimes it's hard to know how a new tool can be valuable, or if it's just kind of like an extraneous fun toy. And so I think what we want to do here is really show how scientists working together with this new tool of AI can help to accelerate scientific discovery.
It's cool. And I know you've been playing a bit with mini models and also models, for example, that would allow us to determine which data we should go get when the data is very vast, which is also exciting. It's another way of guiding research, right? Imagine if you need to collect samples about billions of different things, but you could just collect a few million. Where are you going to collect to build a good model? Great. And Jess, you joined us also later. You're a neuroscientist, but with some foot in technology and AI. You've been both in academia and industry as these other fellows. So what do you see as some of the big challenges for us here?
Yeah, I mean, we've heard some of the themes already, right? Y'all have collected a lot of data, like a lot of data. And with all of that data, we also collected it differently and for different reasons and for different purposes, and we labeled it differently, and we made different metadata, and we organized it completely differently. I'm sure there's some people in this room that are probably nodding their heads going, yeah, I definitely did that. That is...
Thinking about my laptop.
Oh, yeah,
guilty.
It's you know, we have huge data sets, we're talking petabytes of data like we talked about, that are organized very, very differently. So the data alone makes this complex. Figuring out how to curate that data, you really have to kind of take a librarian mindset, and I almost use this word sustainability, because thinking about how we're going to reuse data, that's going to be a mindset change in how we look at data and how we store it. So we have a lot of complex data, various levels of metadata. How we store that data takes a lot of work. Then how you just compute all of that. You know, I'm looking around and I'm seeing some very familiar faces that I know help me think through the infrastructure of that. The pure computing power that you need to run these models is massive. And that takes specialized infrastructure, takes specialized pieces. There's real thought that goes into that work. And all of that kind of has to, you know, even things like finance and all these other pieces, there really is a science to this science. There is a science to the foundation of setting up an AI system. It does not happen organically. It has to happen with intention. Otherwise, you're going to get a lot of piecemeal stuff that you maybe use once. You do a really cool model, and then you don't get to use it again. For what we do here, it's going to take a shift in thinking from project by project to kind of curating a garden that we can keep growing and reusing. That's going to take time and effort. So to me, there's the technology that we have to go and solve, right? But we have very smart people. I'm looking around, I'm seeing all my friendly faces that I lean on for these things. But really, to me, the culture, the mindset's got to change. We got to think about a more sustainable approach. To me, that's the bigger challenge.
And you know, leading from that, so one of the things is obviously to build these great models that help with quest, with hypotheses, with conclusions. But another aspect, you know, in terms of culture is also how we all become more AI literate in the work we do every day, already with existing tools or modifying existing tools. And I know this has been also a passion of yours.
Yeah.
Can you tell us a bit, how do you see this? What have you done here to try to foster this AI literacy?
Yeah, I'll go to my industry experience here because I was at Microsoft when Copilot started rolling out, right? And we were all...
I'm sorry.
Exactly. You should. Thank you. Thank you for acknowledging my pain. The first version of Copilot was a really angsty Clippy.
Oh, it's
Okay?
much better now.
It was horrible. We all had to dog food it, absolutely hated it. The thing would pop up. Do you need help with this? No, I don't. Please leave me alone. And going through that process at Xbox where we were trying to learn, okay, we got it, AI is going to be a thing that we need. And funny enough, being in gaming, we've been working with AI for years, right? Like if you played a game and you played against an enemy in that game, that is AI. That is a version of AI. So I've known AI for most of my career, but it took on a different form, you know? Over time, seeing that kind of translate into how AI could be this kind of co-pilot model or this, I'm going to steal Copilot because that's the one I'm most familiar with, but Gemini, any of them, this tool that's a different way of working and watching that evolution over time happen. Adoption is not instant. It's going to take time. It takes trust. It just takes plain behavioral repetition. It takes experience in testing those things. And you have to reduce the friction to use it. A good example of this is my kid is very good at using AI because she's yelled at Alexa her whole life, right? She knows how to command AI because at a very young age, she was learning how to do prompt engineering by yelling at Alexa. Those are the kinds of behaviors that, I don't use a search bar in the internet anymore at all. But it's taken me a time to switch my mindset and switch that behavior. So I kind of put it in 3 different buckets. You got to reduce the friction to actually use the tool. If it's a pain in the butt to use, no one's going to use it. You have to strategically apply it. I think sometimes there's this idea of sprinkle AI on it, that'll do it. And if it's not done strategically, no one's going to use it. It's true, man. We have to know it's true. And then finally, the third one is culture. You have to make a culture of experimentation, a culture of learning. It's why we do things like Nautilus. It's why we support things like Hack and Learn, is you need the space to test it out. You need the space to feel stupid and feel okay feeling stupid about it because it's new. Experiment and test that out. So the way that we think about it is all of those things. How do we reduce the friction? How do we make it easier for people to use? And then, I think, I'm looking around. I know there's people that are pinging me like, how do I do this in Copilot again? Feel safe to ask those questions. And eventually, you'll get to a point where you start to feel comfortable.
And what was Nautilus? Can you explain a little bit?
Explain that. So Nautilus is this kind of what we call a hack and learn event. If you guys are familiar with hackathons, it's the idea of, going in and generating a new chunk of code or a new project that you want to work on. The Allen Institute's really unique in that we have people who are on the very cutting edge of AI, amazing winning Nobel Prize people, and then you have folks that are like, what's a Copilot, right? So the challenge, I gotta say, I started in September and they were like, hey, make a plan that will serve everybody, and I was like, okay, that's gonna be tough. So we decided to make an event that had a lot of different angles into AI. So we had stuff for folks who have never, or don't call themselves technology experts, so that they could use, Copilot and those types of things. And then we had talks that were very specialized on AI engineering, which is an entire field in itself. And the intent of those types of events is to bring something for everybody to be curious and learn together.
Yeah, and I heard from folks that it was amazing, and some people that are more advanced showed and developed really cool stuff and tools, and others learned how to use existing tools. So,
and we did get you to dress up like a captain, and that was the win for me.
Yes, I will dress up for a good event. So, alumni, be warned. And so, Andy, here we are, and so looking a bit into the future, what are ways, and maybe even unexpected ways, that you think AI can change the work in science, how we do everything?
It's not a question of if it's going to change the different parts of science. It's a question of when it's going to change the different parts of science. I see, the use case that I get most excited about is actually using AI to actually help digest the papers and the daily reading load that I've got. I don't think it's a scientist in this institute who doesn't do that as well today. You can upload your papers to the large language model of choice and ask questions and try to figure out exactly what you know and what you don't know, and ultimately what points you want to change and what experiments you want to do. I think what really gets exciting, though, is how we think about operationalizing this, when it stops being fairy dust and it starts actually being the way we do actual work. And so whether that's in terms of automation, or whether it's in terms of designing experiments, or designing or kind of automating the analysis of data. I think we're really excited about taking this from something that's is a whiz-bang kind of new technology that's only the provenance of the informed, and actually making sure that it's accessible to all.
And you mentioned different parts, from literature search to hypothesis generation to analyzing the data. So can you envision putting it all together as, a circle, like almost a full AI-powered lab?
Yeah, I mean, Grace, you've been thinking about this.
Yeah. I think it's not a package deal, right? We have to, like Jess was saying, introduce individual parts and figure out how they are useful for us. Probably not going to have a machine just read all papers and synthesize them for us. That's kind of the fun part of reading about other people's work. But there's definitely a place where AI models can help us to prioritize what to read and know what's interesting to us and bring us things that it learns are interesting to us in the same way that we might read like a social media feed, right? And so I think there's opportunities there for also serendipity, where machine learning models can help us to look in areas that we might not have thought to look, but that would be interesting to us and relevant to our work. And so in each of those stages, from hypothesis generation to data collection, I think machine learning also can help us to capture our biological data with higher fidelity. But how does that actually look when you're standing there in the lab? Is it like a humanoid robot standing next to you? Is it a machine that does all your data collection? I think for each person's scientific goals, it will look different. And so I think we have to develop a system that allows scientists to pick and choose what's the most helpful way that AI can help us at each of these stages. And for each of us, we all have different personalities. It'll probably look a little bit different for each of us. But there is a place where AI can amplify what we're already doing in all of these stages, and hopefully be able to help us get deeper insight about biology and move the science to the next level.
Rui, you're not just a veterinarian, you're a CEO and a lab leader and a scientist and a neuroscience and lots of things. Tell me exactly how you would like to see AI deployed in your world. How you'd like to see AI deployed in your world.
So, I mean, it has been a humbling experience to even dump my own papers on a model of choice or two to compare and see what do you take from these. It's very interesting because it captures subtleties I missed. It takes slightly different conclusions, although most of it is there. And what is amazing, again, summarizing the literature, but if you want to go and say, given these, not hypothesis generation in the blank, but given these, what would you test next? And imagine if it's a certain concentration of a chemical and at what time. It's pretty good. It's much better than I would do now, even today, right? And some aspects, I'm not saying humanoid robots, but we have our Hamilton robots and stuff. The idea, for example, of continuous readings of the images instead of the end of the experiments and AI interpretation of the cells evolving or sequencing and automatic reading and incorporation. This is where the experiment's going and what the thing you're doing is causing. That, I think, can be a reality in the next few years. I'm an optimist, even if I'm a post-humanist optimist. So I think AI can also help us a lot in enterprise management, right? So, for example, in doing budgets, organizing things, which is something we talk less about, but it would free more time for everyone, to dedicate more time to science or the work they like, or the parts of the work that would require analytical thinking, right? Like in HR, there are parts that are people, right? And it's better if a person is thinking about a person. So summarizing all the parts that can be done by a machine could help the person deal with the person. And so I think that augmented part is good. But I'd like to leave an anecdote. Maybe a month ago, I saw some results from Claude competing with experts at diagnosis of some image of cancer. And it was amazing, expert doctors, 72%. And then Claude, I was amazed, 92% accuracy. But what surprised me is Claude Plus expert. I thought, I had to guess, we were in an audience, I said 94, 96%, it was 74%. So we as experts second guess AI and downgrade it even when it's right. So it's tricky. Not everything is good, not everything is bad, but we're still in a situation where sometimes we have biases. So AI can help, but we can choose or not choose. So anyway, I think one of the most important things, though, is the ability to democratize knowledge, to add transparency to science and reproducibility, to have reproducibility and authenticity certificates. And these, for trust in science and to the general public, I think is going to be critical, that people can go and see for themselves data and see that it has authenticity certificates and reproducibility certificates, and that it can be democratized. And with transparency, how much did it cost? How many people? How many years? What are the results? I think we need to do this.